Welcome to our lecture about Internet security, weakness and targets. Today we want to have the second lecture about weaknesses of the World Wide Web. We have already discussed the many attack points of an interconnected IT system on the level of the operating system of the single components, on the level of the communication protocols, the internet protocols, on the level of the human failures and the human factor. And we just started the discussion of attacks and weaknesses on the level of using the World Wide Web. We have already started to do this. We can distinguish between risk on the side of the client that's using resources, serving in the internet, running web application on his web browser. Here, about the attacks that are possible, we already discussed. And then there are the other side, the side of the resource provider, of the service provider, of the resource provider in the internet on the side of the servers. So we have to distinguish when we discuss risk, security risks in the World Wide Web. We have to distinguish between risk on the client side and risk on the server side. And this lecture, the second lecture on weaknesses of the World Wide Web, is the discussion of risk on the server side. So the first lecture, when we discussed risk on the client side, we mainly focused on the target of exploiting web browser and spying out personal data. This was possible because a browser automatically records all kinds of activities of a user. And if anyone gets access to this activity logs, like history file, bookmark file, or other, then he can get a lot of information about the user. And the second point we discussed when we discussed on the risk on the client side is security risks with using Java applets, with using JavaScript programs, PDF, Flash, and ActivityX controls. This was in a lecture, Weaknesses on the World Wide Web 1. In this lecture, the weaknesses of the Web 2, we want to speak about problems, risk on the server side. And here there are mainly two things that can happen. One is to break into a web server to do some damage, and in the second part of the lecture, we want to speak how to secure the web services. In detail, we will discuss the following attack scenarios to give you an idea. What is the problem? What are security risks on the server side? We start with CGI attacks, with URL attacks. Then we will discuss SQL injections. We will discuss cross-site scripting and cross-site request forgery. And we will discuss or give a short introduction into attacks on the internet applications. And then at the end of the lecture, we will give a short overview about how to secure web services. We will speak about service-oriented architectures, what the people try to do to make the use of this service-oriented architecture more secure. There are new security problems in such a distributed world, and we will give a short view on ideas, also standards that are provided to run service-oriented architecture, to run web services more securely. So let's start with the main idea, the main goal of attacker attacking web servers, that is, to break into a web server. The web server are the central system for providing information in the World Wide Web, for distributing information in the World Wide Web, but not only in the internet, but also when the internet technology is used inside a company. So also it is a main focus point also in intranets. The key task one solves by means of the help of such web servers is all kind of e-commerce applications, all kind of groupware applications. They are organized by means of web servers, all kind of database access over the internet. Here, web servers are involved. Access to company-specific applications are organized by means of web servers. Of course, multimedia, enhancement, audio, video server, all these applications, these very popular applications, are using web servers, are using web technology, are accessing web servers. So it is a very attractive goal for attackers to see how they can break into web servers. So this importance of these tasks make web servers the main and most attractive target for attackers. One have to see this, and then it's important to a little bit understand what are the security risks. I mentioned, like also in other lectures, also some attack scenarios that are no more valid. The reason is to show you, to explain you on which level one has to think about security, on which levels one has to be aware that there are attacks are possible. Let's start with discussing ZGI attacks. You remember many web pages contain elements which invoke programs when they are loaded. For example, to start a search machine, to find a solution, and to send a solution back. Or to save some user data in a database, an application database. Or to provide a user an overview about some data that are in a database that can be accessed over the web server. And the standard, the interface between the web server and the application is ZGI, the Common Gateway Interface. We have discussed this when we discussed about web technology, so you know the task and you know how this ZGI is working. So ZGI provides an interface for the communication of the web server and the application. The application that are started to provide some results that is requested by a user in the World Wide Web. So ZGI regulates the data communication, for example, the passing the data variables, passing the data from the web server to the relevant program, and then vice versa to get the results of the program back to the web server so that the web server is able to send this data to a user, to a web client. So here we have the web server, and the web server is interacting with the web clients, and the web clients request some website, for example, some dynamical website that needs to be produced or needs to be designed by data from a certain application. Application here is in a program. So we have the ZGI for interacting the web server, handing over the data to the application, getting back the application. So the client provides in the request the data, the program parameter that then the web server forward to the program the program processes this data, and then the program, the web server, gives back the data, the output of the program, to the requesting web client. This is the idea of CGI. And what is a problem? What is the security risk behind by using CGI? CGI often is associated with script language, Perl, but it's not. CGI can also use other programming languages or scripting language as long as the language can execute it on the system. So beside Perl, also Unix shell script, PHP, Python, Ruby, C, C++, CCL, Pascal, Visual Basic, all this can be used for CGI. What is the security risk? The CGI risk, the CGI scripts can be modified in such a way that arbitrary instructions, also dangerous instruction, can be executed after activating the prepared URL. So the URL describes the program that is used, and by manipulating or preparing the URL and information behind, one can do bad things. One can do such bad things if there is an insufficient examination of user input. Because typically the user input provides the parameters that are handed over from the web server to the program. And if this is not correctly examined, then it's possible also to input some dangerous, some malicious content that is later handed over without examination to the program behind. So due to the insufficient examination of user inputs, the execution of instructions, of manipulated instructions by malicious inputs can be initiated. This is the main scenario. And I will discuss this in more detail by having a closer look to so-called URL attack. So URL attacks are are a typical CGI attack. So the idea of an URL attack is that the URL attacker attempts to break into a web server system by modification of URLs. And this modification, the idea of this modification is to instruct the server to reveal some system files, for example, some very important and serious files like the password file or others to the attacker, so that the attacker can use this information for a later break-in. Let's start with the first attack scenario. It's a so-called PHF attack, which is no more possible today. The PHF file, that is a CGI script, and in a typical web server installation, this recedes in the directory /CGI -bin/. And this PHF file is supposed to provide user lists. So information about users of an application. Now, by means of a new line comment, the script could be forced to reveal, for example, the password file of a Unix server system by means of a web browser. And this is what is done. There is a victim system, CGI bin, and then PHF question mark, and then the request for getting the password file, and then the browser displays. In the past, the browser on the user side could display the password file, could get the password file. And you remember, this is important to get this password file for any kind of password attacks we already discussed in the past. There is a second attack scenario, very similar, but now not with a PHF file, but with a test CGI file, similar like for the PHF script. Same attack scenario is possible also for the test GGI script. And by means of a new line comment, also test CGI can be misused to give out password files. Now you see same start. Now instead of the PHF file, there is a test CGI file, and by means of this new line comment introduced in this place, the system gives out the password file. So it's an implementation error, but with fatal consequences, because this is very easy. This can be performed very easily. Attack scenario 3 is the misuse of some special characters. In this case, the misuse of the tilde mark. Also here, in many old systems, the tilde mark was used to access special directories in a short form. So the problem here, an appropriate modified URL can cause fatal consequences. And here's an example. So here you see with slash one access the root file, and then one can access here is also such very sensible data like the password file. Another attack scenario is that by means of such URL attacks, buffer overflow attacks can be initiated. We already discussed in a special lecture buffer overflow, and you remember the idea was by user input by an URL with very long data, one can cause, in a simple case, a denial of service attack. In a controlled, more sophisticated case, one can force the system to execute some things. So the input of a huge URL provides a denial of service attack, a so-called uncontrolled buffer overflow. And if it's more sophisticated designed, this dangerous URL input, then one can use this buffer overflow to start certain programs, and these are so-called controlled buffer overflow. We had already discussed this, so it's not possible to go into more detail. Another URL attack scenario is again using some special marks, in this case the misuse of slash and backslash. So the use of slash and backslash in an URL forces some web servers to break out of their virtual root directory and to allow at least read access to the hard disk or even execute code. Here, for example, to start a trivial FTP server. And here it's an example. The security concept says that web servers can use only resources, access only resources in a certain virtual environment, and the goal of an attacker every time is to try to break out to get access to the resources stored on the system. Let's have a closer look to a second family of attacks against web servers and against application on the web servers. Let's speak about SQL injection. SQL injection, that is also a special kind of CGI attack. It's also a special type of URL attack, and it makes use of SQL, the language, the question language, which is implemented for almost all databases. So attacks are useful on multiple type of platforms, and so the simple reason is that SQL is a database standard that is supported by the most databases. But every time have in mind, such an SQL attack is not an attack against the database. An SQL attack is an attack against the application that's using a database. So the attack SQL injections are very popular in connection with such web application that are using database, and of course most of the web application make use of a database behind. SQL injections are possible when the application is poorly written. Also here it's a problem that comes from a lousy design of the application. The general idea or the general intent is that untrusted SQL statements are passed to the database. Untrusted SQL statements are passed to the database, and then this untrusted SQL statements that cause some special undesired results that can be falsifying database entries up to delete database entries. So the main idea, the basic idea of these SQL injections provide the basis for several types of attacks. The attacker can bypass authentication. So you get a login granted without a valid username and a password. There is another type of attacks that are based on SQL injection, that the attacker can get unauthorized data access, that the attacker can view confidential data, that the attacker can modify databases, for example, insert new entries, or falsify entries, or even destroy tables, and more. So what is the most common procedure with these SQL injections? That is the submission of data by means of forms. Submission of data by means of forms. For example, the login fields of a web application. Here is an example of such a login form. You know this from your experience. There you have a username, then you have to input some data on the client side, then there's a password. The client has to input some data, and this data are transported to the web server, and the web server hands it over to the application. To give an example, here an example of an SQL query, typical SQL query. Select from users where, and now one has to, now it's explained what are the user. User is characterized by the username and a password, and then some action are performed. So if a user with a valid password is identified, then something can be done. What is the problem? If the user forges this input, for example, if the user inserts a string or 0 equals 0 minus minus. If the attacker inserts this here in the form, behind the username, what is the reason? What is the result? The result is that he can immediately bypass the authentication procedure. Here is it written, select from user where username, then comes the input, or 0 equals 0, minus minus. What is the problem? Now, yeah, of course, the 0 equals 0 every time is true. So this statement is true, regardless what's with the first term. And the next thing is, these two minus indicate comments. That means by means of this two minus signs, the request that the password needs to be checked is considered as a comment without influence of the proceedings, what's done. So by means of such a simple injection inside an SQL statement, the attacker can bypass the authentication mechanism. So the problem here is he can do this, but then attacker needs to wants to get to see the results. So this is a problem one needs to solve, but this is often done via debug the output. It is also possible to manipulate a database. And here the idea is by using code like drop table users minus minus. Here the attacker finishes the first comment and then executes a second comment, and the second command is to delete table entries. Yeah, by inserting this short sequence string, finishing by means of semicolon, finishing the first attack, so the first command, then giving in a new command, he can do really dangerous things. Of course, one such an attack is possible and successful. Of course, it needs to be successful. It needs that the database is configured not in the right way. The user, the external user, should not have the right to execute SQL commands like delete. So configuring the database in the right way, that users can only view data and that they have no rights. One can prevent this. But if the database is not correctly configured, it's so easy by means of SQL injection to manipulate the database. So some server-side scripting environments cut off SQL statements after semicolon by default. Oh, this is a security measure. So then it's finished and it's no more possible to give in another command. So what is the advice? The advice is whenever possible, the web applications should only work with accounts that just have read access to database. And those tables which are intended to be public. Because then, even if it's possible for the attacker to insert, to perform such an SQL injection, he cannot cause big damage. He can try to get access to the data, he can view the data, he can read the data, he or she, but cannot manipulate or delete the data. There are more countermeasures. So the attack becomes complicated if the attacker is not provided with any feedback needed to locate the SQL injection weaknesses. So this is, we already discussed in former lectures, to prevent that the attacker, it's not easy to get insight for the attacker, what database is used, what version is used, whether it's can be misused, whether it's affectable by SQL injection. Another very important countermeasure, also if you do your small application in any way, is to sanitize user inputs. Sanitize user inputs so that it's not possible by means of the user to give in SQL comments. So an external filtering should be implemented to only allow legitimate requests to the database or to the web application. Best solution avoid building queries from SQL comments and user inputs. So how to do this? It's a simple idea to replace the user input by some prepared statements, so that the user cannot give in own input, but that the user has to select from pre-prepared statements. Then in this way, one can avoid that the user tries to attack system by SQL injection. So avoid building queries from SQL comments and user inputs by replacing them with pre-prepared statements or database stored procedures. The next family of attacks, again, web servers and web services. These are the so-called cross-site scripting attacks, XSS. This occurs when a web application gathers malicious data from a user. Mostly, this is done in form of an hyperlink. Be careful. Sometimes people appreciate the cross-site scripting with CSS. But CSS is cascading style sheets. So be careful to distinguish these things. The good abbreviation and typical abbreviation for cross-site scripting is XSS. So neither static HTML pages nor dynamic web pages are risky for such cross-site scripting attacks as long as the operator only delivers its own content. In the moment external content is included, there is a danger of this cross-site scripting attack. So this cross-site scripting is only a threat if the user can influence the output of a dynamic website by his/her input. Otherwise, one cannot apply such cross-site scripting attacks. After the data is collected by the web application, an output page is created for the user which contains the malicious code. This is the main idea. So in the output, the user receives from requesting a dynamic website, he or she gets malicious data inside the answer page from the server. And then this code will be executed on the user's computer, on the side of the client. Most likely, the web-based discussion forums or weblogs or wikis where users can submit messages are targets of such cross-site scripting attacks and attackers. These web pages where a user create content, discussion forums, weblogs, wikis. Here I will give an example. So to such a web forum, an attacker gives the information, hello, this is my message. Then within the script tags, there is some malicious code, and then have fun. And if the user accesses this information, he can read what the attacker has wished, and the malicious code is processed on his client. The malicious code between the tags are performed on the computer. At least as long as it's allowed on the client side that scripts can be executed. And it's the same method, the same attack method does not only work with the script attacks, but also works with other tags, for example, object, with applet, with embed attack. Attacker can perform in the same way such a cross-site scripting attack. So it's also possible that the user sent himself the malicious code when activating a link. it's a little bit more complicated. Let's have a look here to the example. The user, there is a link, and he requests from a good site some links, and then there is my comment, and he gets back my comment, the malicious code, and then click here, and the user will be forwarded to the real server. Afterwards, the user will be forwarded to the real server, and if the server delivers the page containing the malicious code, it will then be executed on the computer of the user. Usually, the attacker encodes the submitted string, here the dangerous malicious code, in a hex format so that it looks less suspicious, like in this way, to hide this so that the user do not really see what's going on. Here comes another example, an example that illustrates the name of this attack, the name cross-site scripting. Cross-site scripting takes place if code from another malicious server are injected into a website. There is a crossing of the content. This attack is often used to read cookies of a user and get access to accounts on e-commerce sites like eBay, PayPal, and others. We already discussed this. We already discussed the things around cookies when we discussed attacks on the client side. The idea here, and the idea is shown best with a short example. Example is here. It's a website, a goods website. Then there is some action from this evil, from the attacker side with a method, and then input name is cookie, and then script cookie value are sent and can be seen by the system. So here is embedded form, the embedded form that calls the action that the cookies are sent to the attacker. Here is in short graphic. We have victim system. Victim system is activating a link to a trusted server. The trusted server sends back a cookie, and then this cookie is sent to the attackers station, to the attacker server, and then attacker is able. The attacker in the beginning injects some malicious script in this cookie, so that if the cookie is activated, if the request is answered by a cookie, there is this malicious script in, and then here the attacker can see and read the cookies. Is this dangerous? Is this dangerous to steal cookie information? It seems, at the first glance, it seems to be harmless. But since attacker can extract the session ID from the cookie information, it could be a really serious attack, at least in the moment when the real user, is accessing the website. So by means of the session ID, the attacker can establish the server, can establish the connection to the server, and he can immediately jump into the session. There is no no request for password, no name, because this was already done. This is a session ID of if this is a session ID of a running session, then the request for username and password was already fulfilled by the real user. So this makes sense only if the session ID is valid just in this moment. And here this shows that with this cross-site scripting attack, it's important for the attacker to immediately get access of this cookie. And then sometimes one speaks from session hijacking. because with the session ID, the attacker can jump into a session of the real user with a web server in the moment when he is logged in and accesses the web page. What are countermeasures against such cross-site scripting attacks? We have to look one side on the on the owner of the website. The owner of the website should never trust inputs of the user and always filter metadata and special data and symbols. Countermeasures against cross-site scripting on the user side. The user should only follow links from the main website he or she wants to view. So this eliminates the biggest risk to follow a link to an attacker site. Another countermeasure is that always works, deactivate JavaScript. Deactivate JavaScript in the browser settings, at least for that sites where it is not needed. Cross-site scripting can be executed automatically when opening an email or an email attachment or reading guestbook entry. So there is a various number or bulletin board post. So one should be careful if the message comes from an unknown person. And then, of course, also this is a very general countermeasure against many types of attacks is apply security patches. Apply security patches to your software so that, for example, the malicious code cannot be executed on the computer. Because as soon as such an attack becomes known, the designer of the software, designer of the application, start to think countermeasures against this attack. Let's have a short view on what is meant when we speak about cross-site request forgery. CSRF, cross-site request forgery. This attack aims to forge a privileged user, typically an administrator, of a web application to send unintended requests and therefore perform an unwanted action. One counts this attack also to the family of confused deputy attacks. Here the attacker's objective could be, for example, to privilege evaluation, to get privileged evaluation. That's the goal is to attack an administrator, to make the attacker an administrator. The attack vectors can be cross-site scripting as a start to prepare a malicious link in a website that the victims trust. Another attack vector could be social or reversal social engineering. The trick is the victim to click a link during the conversation, or the local exploit, for example, using admin's computer or others. This is an example of such a cross-site request forgery. The user is logged on his online banking account and doing some transaction. Then the attacker attracts the user to visit his or her website where he or she has prepared an image referring to Bob's bank, if Bob is a user. Like this example shows. So while the online banking connection is open, the user goes to this website and sees the image of his bank. Now, while the request comes from Bob's already authenticated computer, and browser, not computer, browser, the bank accepts the forged request. The bank refuses the request because the bank thinks this comes from the authorized users. And this exactly shows what's meant when we speak about the confused deputy. The confused deputy is Bob's browser. Bob's browser is authorized to do numbers, and now there is a confusion so that also the attacker can access, can trigger some comments on Bob's online counting. When we speak about applications in the web, then new and modern applications are service-oriented architectures. So the situation today is the applications are based on such a service-oriented architecture, SOA, that make use of web services. So SOA, in a certain sense, is an abstraction of what's done with web service, and this becomes more and more popular. The distributed web services, meanwhile, exist to a large extent and are very popular in usage. Such a service-oriented architecture, also with web services, is one basic technique also for cloud computing. So that's a real important technology. And what are the security issues? This service-oriented architecture works with the protocol, text-based, message-based protocol, with a SOAP, service-oriented architecture protocol. And the security issues here is running and designing such web-based services and such service-oriented systems is that these messages have to be secured across different domains in a special way, and the authentication has to be performed across different domains and different security domains, and authorization has to be performed over different security domains. And to this end, the new mechanisms are needed and new protocols are needed to fulfill the general security objectives. Security objectives, our security goals, like we discussed, like confidentiality, integrity, authentication, authorization, and others. And to this end, various web service security protocols were designed to capture challenges like establishment of a trusted relation, the federated identity management, or secure conversations. So new protocols were designed to allow this, also other reasons. And here is only a short overview about this standards. This is the zoo, to say it a little bit respectless, or that is a variety of web service security standards. And this is concerning different areas. We are here in this lecture concentrated on security protocols. These are the red ones. So we have data and protocols concerning dealing with metadata, how metadata can be exchanged, how web services can be discovered, what are the policies that are implemented for such web services. We have here business processes, a description of business processes by standards like people. We have management, web service management, web service transactions, web service reliability. We have messaging, the addressing, the service, the SOAP protocol, the web service eventing. We have XML encrypt, XML signature, and we have this important part of security protocols. The organization that is thinking about this this web service standard is OASIS. HPI is also a member of this OASIS. There is the Web Service Federation, standard concerning Web Federation, Web Service Secure Conversation, Web Service Trust, Web Service Security. Here we have later on a closer look. Web Service Security Policies. Also here we have a closer look. So you see there is many protocols that try to regulate that distributed applications that are designed of interacting web services provided by different providers from different security domains, from different trust domains, can automatically interact to provide a certain solution, to provide a certain result. So a short overview about the Web Service Security Standards, that's WSS. I already mentioned this OASIS organization. This OASIS is an organization for the advancement of structured information standards was proposed in 2004. So it's almost 10 years now in place, and it defines enhancements to the original idea and original mechanisms of service-oriented architectures, to the SOAP messaging. The kernel of the service-oriented architecture is this communication protocol, the SOAP protocol, and so this web service standards, this web service security standards, they provide message confidentiality, they provide mechanisms to guarantee message integrity and message authentication. The standard applies different security technologies. So for example, X509 certificates or Kerberos, and it is based on XML signature and XML encryption, the security mechanism coming with XML. So a web service security header consists of security token. Security token provides the XML signature, provides the XML encryption with information. The signature element represents the XML signature and contains references to the elements which are digitally signed. It consists of an encrypt key element, and this encrypt key element enables XML encryption, holding a series of reference list elements which point to the encrypted parts of the message. And here is an example. Perhaps it's difficult to see, but a little bit to show that there's a lot of formalism to organize this. So here, this part, so this is a SOAP message. This message is in a SOAP envelope, and then we start with a security token. Then we have the XML signature. Here we have the reference for this. Then we have the XML encryption, the part that describes the XML encryption, and then we have the XML encrypted and signed body. Here starts the body. In the header, the mechanisms are referenced, and then we have here starts the body. Here's the envelope, and then we have it encrypted and signed as it's described in the header. So this is not, of course, not a lecture about to understand this in full extent, but to mention and to connect what we discussed about the weaknesses of web services. What is the answer? What is the answer from computer science to design really the distributed and secure application? So a few words about security tokens. These are special XML structures that encapsulate the security credentials and claims. there are two different types of security tokens, which are defined by the Web Service Security Standards. There are the so-called unsigned tokens, that's so-called username token. That's the username and the password. And the second type of such a security token is a signed token, binary security token, and here it comes with an X05 certificate or Kerberos. These security tokens are used to express authentication claims, authorization claims, and attribute claims. So it's important that if automatically one web service wants to start another web service to get a certain result, they have to discuss what kind of security mechanisms are requested, what they need to implement. So here an example of such a web service security binary security token. We have here the identity of it, then the encoding type, the value type, and then the binary data come. The encoding type here defines the representation of the binary data, and the value type defines the token type, whether it's an X05 certificate or whether it's a Cerberus ticket. Another part of this of this suite of standards is the Web Service Security Policy Standard. The Web Service Security Policy Standards specify security assertions for web service security related requirements. So if a web service wants to interact with another web service, it has to be able to tell the other web service what are the policies, what are the security policies for this interaction. And this can be described by means these web service security policies. The web service policies, there is a protection assertion, what parts, and this tells what part of the message must be secured with regard to integrity or with regard to confidentiality. Then there is a conditional assertion. Here it's possible to describe some general aspects or preconditions of the security. There is security binding assertions. Here is the security mechanisms that are used are provided. This is what you find in security header assertion. And then there are supporting token assertions. This provides a possibility to describe the token type and the usage pattern used to provide additional claims. And then we have web service security and trust assertions, the token referencing and trust options that are used. And this looks in this way. So here only to give you a short impression of these type of mechanisms. Then there is a policy attachment standard and a web security secure conversation standard. The web service policy attachment binds a web service policy to WSDL or UDDI. Beside of SOAP protocols, the two other columns of the web service standard. The web service secure conversation is something like, provides something like an SSL over the SOAP protocol. So the idea is to establish a secure context for a series of messages to negotiate and manage the shared session keys and others. Finally, I want to mention the Web Service Trust Standard. This was, if you remember the picture, another part in this standard suite, in this Web Service Standard Suite with the Web Service Trust. The idea is to decouple service consumer and service provider. It describes a security token service to broker trust, that's STS, so that the user and the provider can establish a trust relation before serving in a certain way. This STS issues, validates, renews, and cancels security tokens. The trust is expressed by tokens conveying assertions. This is an important mechanism. Relying parts is willing to rely on this issued security token. So with this security trust, web security trust standard, the relation between the user and the provider, they are brought into a trust relation by means of a third party. For example, an identity provider that is used as a third party to establish the trust relation between the user and the deliverer of some web service. This is important if you have such distributed world. The web service interact to each other. It's not that the user interact with one web service and gives in his credentials and can follow, but here we have situations that one web service uses a service from another security domain, and it needs to be ruled how this can be organized and how it does work. Then we have the Web Service Federation Standard. This is how to bring web services, how to allow that web services are federated, that come from very different providers and within different security context. It's a specification done by Microsoft and IBM, and it describes how to manage and how to broker such trust relations. It is based, it makes use of this OASIS standards, of this web service standards, of the web service security standard, of the web service policy standard, of the web service trust standard, and the web service secure conversation standard, and specifies the metadata that are needed to allow such web service from different contexts, from different providers to interact. So this Web Service Federation Standard defines extension to the Web Service Trust Standard to enable also pseudonym to attribute and authorization services. So this gives you a short introduction into these mechanisms that are available, that are proposed, and that come more and more into place to make it possible that web services from different providers can interact. This service-oriented architecture and the details about this are parts of other lectures. So here I only gave a short overview what the security mechanisms and the trust mechanisms that are used in this environment. So this concludes our discussion about weaknesses of the World Wide Web. Of course, only here we can give only a few representatives of such type of attacks. In the exercise and the practice work, you will play a little bit around with some of these things. In any case, you see one needs to be careful in using the web as a client, on the client side using a browser, but also if one provides services in the World Wide Web. Thank you for your attention.